Welcome. All right, so this is Chicago JavaScript. Hello.
Hey there.
I'm Justin Meyer. I'm one of the organizers. Actually, Justin Meyer and some other people are actually doing most of the work. I have to make sure to give them credit. So it looks like everyone got something to eat and drink.
Yes.
Yeah, enjoying the good space downstairs. So all of that's provided by Trading Technologies. Let's give them a hand. And why are you doing that?
Oh, yeah.
Yeah, and if you're interested in more of what we do, you can come next month when we should be presenting. But Trading Technologies, we're a trading firm or a trading company that provides software for traders. We've been around. I think we just had our 25-year anniversary, and our main trading platform is completely written with JavaScript. So if you go to our website, tradingtechnologies.com, there's some cool videos you can watch of the trading platform in action. We do some crazy stuff here. So yeah, I'll turn it back over to Justin.
All right. Thank you. All right. So first up, we have Justin Meyer with Introduction to TypeScript.
Thank you, Justin, and thanks again, Trade Tech. Y'all should work there now. This space is amazing. The pizza was great. Really appreciate them hosting us. Thank you again. So, can you all hear me? All right? Is it working? Yeah. Everybody can read this, hopefully. Trying a new thing. Not slides, just HTML. It's getting crazy. Ooh, yeah. So all of this, actually, if you go to, I'm going to talk about TypeScript if you don't already know by the big blue TypeScript here. You can go to bitovi.com, see the Academy link here, go to this TypeScript link here, and you can do this. This actually has exercises, so if you want to learn TypeScript, you can do the exercises. You can go use this as a reference. This is a kind of a guide to TypeScript I recently built and wanted to go through it to present it to all of you today. There's a magic slide button that I put right in here, which turns it into more of a presentation mode. All right, so who's used TypeScript here? Okay, for those who have used it, how many people have used it like actively day to day? Okay, for those who have used it actively day to day, my apologies, this will be rather boring for you. This is not going to advance TypeScript. My goal right now is to take people who have never really looked at TypeScript before, describe like an overview of the language, the basic things that you need to know so you could start a TypeScript project. So we're going to talk about why you might want to use TypeScript. I'm going to show an example of what I think is the real nice thing about using TypeScript. It's integrated IDE support, so you can see errors in your IDE. Then we're going to go through the basics of what TypeScript really provides, providing types, how to type your functions, how to type your classes, how to define interfaces, which are in some ways like shareable types. And we're going to talk about generics, which are a way of passing a type as an argument. We'll see what that means a little bit later. Now, part of this is designed to, this is a training that I've tried to design. So with that in mind, if there are any questions that people have while going through this, I know it's presentation mode right now, but please just stop, ask questions. I'm really looking for feedback on how to teach people the basics of TypeScript in a way that they can understand. So we can all learn something together tonight. All right. So why IDE or why TypeScript? Really, it's for early error detection. That's the primary reason that I would use it. And if any of the TypeScript pros in the audience have other good reasons, let me know. But that's like 90% of the reason why to use it. I think the other reason to use TypeScript would just be it at least can allow me to think through by adding types to my functions and things like that. I'm thinking through a little bit more on what I'm doing. That has advantages. But really, the advantage here is that if I have a greeter function that I've said takes a string, and I passed it a number, my IDE is actually going to highlight that and say there's an error. And if I try to build my application, it's going to give me a warning saying I can't assign a number to something that's taking a string. That's the big reason. And it does this through, TypeScript does this through type checking. JavaScript by itself is an untyped language, right? When you define a variable in JavaScript, has type by the value. It's typed by the value, not by the variable. What that means is when I create a number in JavaScript, if you were to like open up the CPU and take a look in the RAM, you would see bytes written out that represent like a number. It would be, if it was a number, there might be a 2 that represents this type as a number and then the actual value of the number. If it's a string might be the number 3 identifier and then the actual bytes of the string. In JavaScript, the value contains what type it is. It's not just like raw bytes, it's like a descriptor, and then the bytes. So this means that like JavaScript, you can call a function, clearly this function expects a string, maybe it would work with a number through type conversion. It does not expect an object. What would this inner HTML be for the JavaScript pros in the audience? What would this output?
Hello object.
Yeah, hello object. And that wouldn't even throw an error, right? You wrote invalid code. It's clearly not what anybody would want, but you could publish this application and you wouldn't even see an error. TypeScript will get ahead of that. So I'm just going to show, kind of do this first exercise on its own, because just to show what it looks like to install TypeScript and just write some basic TypeScript code, compile it to JavaScript, and then run it. So let's see if I can turn this. Can you hear me if I talk like this? Is that, no?
Oh yeah.
Oh, okay. Let's try to bend it down.
It's
All right.
disguised, but you can bend it.
Okay. Thank you. First thing, if you want to use TypeScript, install npm, and then once you've installed or node in npm, you can just install the TypeScript compiler globally. And then once I've done that, I can create a TypeScript file. So I'm going to create this y hello world file. And it's empty right now. If I did it in the right place. Oh, not. Is it kind of thrashing? Just let me know if I'm typing too much and it's not working. So TypeScript files end with TS instead of JavaScript. I'm going to build some basic TypeScript code. So all this does is it creates a greeter function that says it expects one argument called person, and it needs to be passed a string. I'm going to actually pass it a string and then write out the result to the inner HTML of the page. To compile this, you run this TSC. This is the TypeScript compiler with the name of the file that you want to compile. There's a million options and things like that, but this is kind of the hello world example. When I do that, it's going to produce a, oh, I forgot to save this file. Run it again. It's going to produce a JavaScript file with all of the type stuff removed, right? But the advantage of this, and you might be thinking, okay, well, I could have just written the JavaScript. Well, again, the advantage is here, if I were to change this to a number, one, my IDE is already telling me, okay, you cannot, this is with Atom, by the way. I'm using Atom, which is, it works really well. I think for those who use TypeScript, who use VS Code, WebStorm, one person, Atom, me? VS Code is, I think, the most popular for sure. I use Atom because I use it for a lot of other projects, and it works. And you can see here, with Atom, I can hover over, and it'll give me the warning that I'm trying to pass a number when it expects a string. And similarly, if I were to try to compile this code, it will give me a warning as well, the same warning. So this JavaScript file is what you would actually send to the client. You wouldn't send TypeScript. You would compile this, and Webpack can do this compilation, and other things can as well. But we're not going to get into that right now, or in this presentation. So another quick note on the IDEs, and a little bit about configuring TypeScript. So TypeScript has a tsconfig.json, and this allows you to configure a whole bunch of different behaviors for TypeScript. I'm just going to touch upon some of the more common ones. The first is the compiler options, which this controls how the compiler actually behaves. Let's say you want to build to ES5 or ES6. You can control how you're building out your TypeScript. Do you want to write out CommonJS modules or ES modules? You can control those kind of things in here. There's also linting options that allow you to specify if you have a local variable that's never actually used. Do you want to do you want to give a warning or an error about that? There's a million of these options as well. It seems like to me, has anybody done a conversion of an existing project to TypeScript? Yeah? Did you, it's my understanding, I've never done that. It's my understanding you slowly turn on more and more and more of like aggressive TypeScript checking over time. Is that how you did it?
We haven't gotten there yet.
Okay, you're working on it? Okay. I think if you are converting something to TypeScript, you can make it very relaxed, and then you can slowly make it be more aggressively typed. The IDEs, as I mentioned, VS Code, probably the most popular. Looks like it's the most popular here. There's plugins for that. Atom, which is what I use, and WebStorm all support integrated warnings with TypeScript. So now let's get to the actual typing of TypeScript and see what's available. So TypeScript supports all the basic types that you would expect, but let's look at the syntax for declaring a variable given a type. So if I wanted to say is carnivore is a Boolean, I can do it like this. Now we're gonna see later that if I just did this, if I just did is carnivore equals true, TypeScript will implicitly assume there's a Boolean there. So you don't actually need to write it, but this is really the syntax in general is colon, then the type to specify the type of a variable, a type of parameter, return value, things like that we'll see. So yeah, here you can define, hey, say is carnivore is a Boolean. Here's for numbers, strings. You can notice that it's kind of lowercase for your primitives that you're using. If you want to do an array, there's two ways. You can do it kind of this, at least for me, like C-ish, Java-y kind of way, or you can do it this way. I do think there's some cases. I'm not sure. There's some problems that I've
And then up a little bit in under one, it's interesting that you can put strings with pair, like string templates. Is that what
Are you talking about this right here, or line one?
The quick tip one, actually.
Oh, this is oh, I didn't have it for some reason. Oh, there's the ending. There it is. This is the template literals in JavaScript. That is part of ES6, and they support actually limited templating. So this is like built into JavaScript, not even TypeScript. Oh, one thing I forgot to mention, TypeScript is, I think, technically still a superset of JavaScript. So like, you can write just JavaScript and TypeScript will be fine with it with the right compiler options. So arrays, this defines essentially an array of numbers. Another syntax that you can use, I actually prefer this syntax. This says raptors is an array of strings. There's also, you can define like what an object should look like. This is saying a user is an object that has a name that's a string and an age that's a number. You typically never see this. We will a little bit in this presentation. You will learn about interfaces later, which you would typically, you'd write an interface and then use the interface. But you can define these like little inline definitions of objects, just like you kind of do for arrays. So you can define tuples to say like, oh, I've got an array of a number, then a string. So if someone put a string, then a number, this can error. This can be really nice now with the spread operator and things like that in JavaScript, where if a JavaScript function returns an array, you can destructure that very easily. Those APIs are becoming more common, so this is really nice in TypeScript. There's enums. I'm not going to get into those. Any that's kind of your standard JavaScript variable that allows you to set it to anything you want. I don't know, you really typically shouldn't use that, but you'll find places where your code suddenly it's thinking it's got an any return argument or something like that. So any is a type in TypeScript. Void is equivalent of undefined. There is no return value. There's even never. So if you had a function that's always going to throw an error, you say this is the return value of this function is never. It's kind of an interesting case. So as I mentioned, TypeScript can do type inference for you. So when you define a variable and you say, oh, this is a string, and you're kind of setting a variable equal to an object literal or a primitive, a literal primitive, like this is just equal to the string Sally, it'll infer that name is a string. And then we did the same thing for height, and if you try to then set name to the string height, TypeScript would complain for you automatically. So that's probably my favorite part of TypeScript is its type inference. I wish I could do it over the whole app and you never had to assign any types. But this makes it so that you can get started with TypeScript without having to like go through every single line of code and type the whole thing. So similarly, if you had a complex object like this, an object literal, you can see here when you try to set name to a number, it's going to throw an error, and that's because it knows that name should be a string. It can even do things through functions. It can say like, oh, hey, multiplier is two numbers, and we can see that the return value is an expression that's multiplying two numbers, which has to return a number. So if you then try to set like a string as a result of a multiplier call, even without expressing what the return value of the multiplier function is, it just knows what it is and would give you an error. So again, that's the kind of, you don't have to provide a return value everywhere, a return type, sorry, you don't have to specify a return type everywhere because it can infer it for you. You can, they call it type assertions, is when you want to specify that one thing is of another type. So if I had some value, which I'm saying is any, but I wanted to say that, no, I want it to be treated as a string by the compiler, you can do this, you can kind of put these brackets and put your type before it, and it will treat that as a string. People don't use this syntax much anymore. Does anybody know why? Because it conflicts with JSX. It doesn't parse well with JSX if you're using JSX. So this is now the recommended way of doing that. If you're using a React project, you convert this, or you do a type assertion like this. Are there any questions before I go on? Is it making sense? All right, so let's see how to decorate a function's arguments and return value. We've seen this already a little bit, where here, if I wanted to add function that takes two numbers and returns a number, I put :type after the arguments and :type after the kind of function, the parentheses here to specify what the return value is. And then I would get warnings if I try to call add with what it did not expect. So it can, what's really nice is that it figures out what, even if you have it can do this this is a little bit of type inference. It sees that we're returning a number or string, a string in this case, and it warns us. So TypeScript supports all of the fancy ES6 things you can do with functions, such as optional parameters, REST parameters, things like that. Let's take a look at it. So if you wanted to say teeth does not have to be provided, you put a question mark and then the type. So this allows me to call build dinosaur with the number of teeth or without the number of teeth. REST parameters. This is available in JavaScript if you've never seen this before, but you can also provide a type for it. So here I want build dinosaur to take a breed and then basically arguments, many arguments as I want that are is called DNA essentially. So here's the name, and then I can just pass it an array of, or not an array, just arguments that I want to be comprised this DNA argument here. And I just say this is an array of strings. I'm typing it as an array of strings with DNA should be. Now this is kind of a side, this one to me is very interesting because I write a lot of dynamic code. And if you're familiar with JavaScript, JavaScript functions can be called with whatever this you want. So here I've created a dog object and I've got this bark function. And you can see here it's calling this.name says woof. And I can use the call operator to call bark with whatever this I want it to be. So I could call it with an address or I could call it with dog. If you're using the strict bind call apply flag when you're compiling TypeScript, you can use that to specify what the this should be. So I can say my bark function, what I'm doing here is saying my bark function has to have a name. And the name has to be a string. And then TypeScript can actually will blow up if you are calling dog.bark on something that doesn't have a name property. And that's very useful when your this can be dynamic in JavaScript. All right, classes. So who's been fortunate enough to at least use classes just even in JavaScript? So most people are on that now. That's good. Through Babel, I assume, I'm just curious, who uses browsers, the only browsers that they support actually support classes? Who's still got to work on Internet Explorer 11 here? Who's got to support it? Oh, you poor unfortunate souls. Very sorry for you. So classes are in all modern browsers, but TypeScript also supports classes and then takes them to the next level for typing. So here, I'm creating a park employee class, and I can specify that its name property needs to be a string. So if you want to define essentially public properties, they're public by default, we'll see that a little bit later, you just do the property name : the type. And TypeScript will make sure that if somebody called, I'm not showing here, but if someone called new park employee and eventually name could be set to something that was not a string, it would throw an error. So when a class gets instantiated, when you have new dinosaur here, the constructor gets called. and you can specify the arguments of the constructor like this. So this is just like a function. It's no different than the function, but there are some cool syntactical stuff you can do with TypeScript in the constructor, and we'll see those in a moment. Here, I'm showing that you can define initial values. So I think Chrome does support, Chrome's classes support member initializers, right, Kevin?
Yeah.
Yeah, but only Chrome, right?
Firefox flag.
Oh, behind the flag. Okay, cool. So this syntax minus the type part is actually available and starting to be available in browsers. In TypeScript, you can also initialize age to 0. So here you can see I'm creating a dinosaur, but I didn't set age on it or anything, but it has a default age. It has 0 as the age. Now there's this shorthand. This is very common where your constructor takes something that becomes a property. Like this, I write this code all the time where I got to take something from the constructor and set it as some property. They have a shorthand for that in TypeScript, which is pretty cool. You can say, if you put public before the argument name, this will default to making name a public property that is a string. So it's kind of a shorthand for this and this. You don't have to do that. It gets removed just by adding public here. Inheritance works just like it works in JavaScript classes. If you inherit and if you inherit and your parent has a constructor function, you must call super before you do anything with the same arguments it expects. So here I'm calling super, and now we'll call the constructor. It also supports static properties. So here I've got, I want to keep the number of Dino Cage instances. So every time I create a Dino Cage, I want to increment a static property. I can put the static keyword in front of my property name and initialize it as well to whatever I want. This also is supported in Chrome now, minus again the typing. This version is basically the same thing, so I'll skip it. Like I said, by default, all properties are public, but what I think is cool for TypeScript is it supports private and public. Who's from a Java background here, by the way, and like that kind of language? So this, you've got to love this, right? This is your kind of JavaScript. So here I'm going to create a private DNA property. I'm going to define a private DNA property, and I'm trying to read it from the outside. You will get an error. You won't be able to compile. Yeah.
So but in the compiled, whatever gets compiled, there's really no way in JavaScript to hide a variable.
Yeah. It's only like compile time hiding. Well, actually, there are proposals that work, and I think there is the secret weak map way you can use weak maps to actually hide. Right? There's a way. Right? I forgot what the way is exactly. Oh, it's your own class. It creates something, and it only knows the key to look up through a weak map. Yeah. There's a way. I can show you after. Yeah.
It's the same in Java. It's only compiler.
Oh, okay. Cool. So you can do runtime things to like go get that. Brutal. Cool. So someone does private, you're like, I'll show you. I'm gonna like do inspector reflection APIs to go get it. It'd be awesome. There's protected as well. So protected only allows yourself and types that inherit from you to access. So here I've got dinosaur, and I'm going to extend dinosaur to create genetically modified dinosaur. It can access teeth count, but it cannot access DNA. It also has a read-only modifier. This is kind of like saying the property can never be set. So here I've got a location. I say that's read-only. If we try to set that, it complains. So TypeScript, like Babel, can also do this with some proposals. can handle this for you in certain situations that JavaScript has trouble with it. So you might have all seen this case where like, what I want to do is call, do a set timeout and write out my this.name. Well, this doesn't work because the this in here is going to be the window really. It's actually it's not going to log undefined yawn. It's actually going to log empty string yawn. Because the window actually has a name property. I'm getting way in the weeds right now, but thinking of it as undefined yawn is good enough. So we all hopefully have seen arrow functions. If not, you're welcome. Arrow functions, they retain the this where they are defined. So this inside here matches the this outside of the arrow function. So in this case, when we call yawn, it will do a timeout and then log T-Rex yawn. Now, what TypeScript can do is, well, I'll kind of show that. This is another common example where like you're going to pass dinosaur roar to a set timeout. And when that gets called, it's just going to, this is going to be the window again. It's going to have undefined roar when you define methods like this. TypeScript allows you to define bound methods to your this, so that here, if we create a dinosaur dino builder, get its roar function, we can call fierce with the right this, because it is already, the roar function is automatically pre-bound to its this. Again, if you're coming from like, I know C#, it just does this automatically. I don't know if Java does. Does Java does this automatically? That's always bound to its, yeah, I guess most class-based languages would do that. All right. So now we got two more. We're going to learn about interfaces and generics. And generics is where things get crazy. Interfaces in TypeScript are really just a way to define the shape of something and then be able to reuse that all over the place. So here I can say, hey, I've got an interface as a dinosaur. It's an object that has a name, breed, height, and location. And then I can use that in my functions to say they need an object that looks like this. But these don't have to be, the nice thing about this, it doesn't have to be like an instance of dinosaur. Interfaces are great if you're not familiar from like other languages that support them. Interfaces allow kind of loose coupling of your types, right? You don't have to have inheritance, which kind of locks you down to implementing a particular, you're basically one interface you can implement. You can have a class that implements 5 interfaces, 10 interfaces, as many as you want. And then you can have functions that essentially say, I just need this. It's kind of like duck typing a little bit. It's like, I just need it to have these things and I work. In reality, what I've written here isn't even very good because this function only needs an object with a location. So its interface should just be like, something, I just need the location. I don't care what else. It doesn't really need to be a dinosaur because I'm using so little of it. Optional properties, just like optional arguments, are supported in the same way. I can define the interface and say, hey, height. You don't really need to have height to be a dinosaur. So classes can say that they are implementing one of these interfaces. So you can say, here I've got a clone dino class, but it is implementing all of these properties. And that's how then, if you pass a class to some function that says it needs a dinosaur, it would know that clone dino is already of type dino, implements dinosaur, so that it can be passed to that function. Yeah.
And you can implement as many interfaces as you want. You say dinosaur implements.
Yeah, you can do many. That's the whole benefit of interfaces, because you can do hundreds of them if you, well, not practically, but yeah. A lot of them. Like if you're, anybody program Angular here? So that's all the TypeScript people. So like TypeScript and Angular are like, hand in glove now. And even to like, TypeScript, Angular to its lifecycle hooks are like ng destroy and stuff like that. You have to say you implement ng destroy for Angular to know to even call that function. So if you're using Angular, it's like all over the place. So you can, this we kind of already saw, talked through that one. So sometimes, we talked about type assertion a little bit. Sometimes you want to be able to like have an empty object, for instance, and add properties to it over time. This doesn't work in TypeScript. It'll throw errors. So what you can do if you're building up your property over time, you could say, hey, this empty object, we really want to treat it like a dinosaur, even though it's not really a dinosaur to begin with. Add my properties, and then now my object everywhere else should be treated like a dinosaur. I don't think people really like it when you do it this way, but it's kind of a nice escape hatch for old code, especially. So, I like this one more. It's very common to want, it's very common that return values are interfaces. This is just kind of showing a very common use case where like, hey, some function that I call has a particular response. I would define an interface, and I would set that as the return value of a particular function. Okay, so there's interfaces. Now the last bit is generics. So, and this is probably the hardest, weirdest part. Let's say I have this JavaScript function here, and this takes a value, and all it's going to do is take that value, whatever it is, and wrap it in an object with that value as its value property. And we want to be able to use this, and maybe our existing code was using this all over the place with numbers, with strings, whatever we wanted. And then we wanted to be able to take those objects, for object, for instance, that looks like this, and pass it to various functions, like get dollars, which really wants a number, a value to be a number, and the other thing to be get message, the value be a string. So this would work, but in TypeScript, if we actually passed the high object, which is a value as a string, if we called that, if we called get dollars, which is expecting a number, TypeScript would not throw here, right? TypeScript would look at this code and be like, that works totally, it seems totally fine by me, and that's because it is not able to infer that, like, you know, wrap as value. It sees this is returning an object with a value property that is of type any. And because it's type any, it's, you know, it's fine to get passed to either one of these functions. So this is kind of a hard thing to fix. Wanting to be able to like, hey, I want to make a wrap as value function that will throw an error if it's called with, you know, basically we can call it, and whatever it returns is not going to be type any. It's going to be, you know, value type either number or value type string, so that when the return values are actually used places, they will throw errors. So there's a few ways you could do this. Way one, you could, as you get the value back, the object back from wrap as value, well, you could just say for object is really a value and a number, and high object is really a value and a string. Then, as you call get dollars or get message, an error is going to happen. Okay, that's one way. Way two would just be write multiple functions. So to say, hey, value needs to be a string, value needs to be a number, you need to call one of these two functions, and then TypeScript would be able to infer that the return value is an object of type string with a property of a string or a property of a number. If that's not great, then you got to branch your different functions based on what you know you have. What is TypeScript even doing for you? You could also overload. So you could, we haven't really seen this, but TypeScript allows you to overload functions. Here, this is kind of how you define it. So you can define your overload value. So if it's a string that's passed, it's got to return an object that has a string in it. If it's a number that's passed, it's got to return an object that has a number in it. Finally, you take any and then you just return this. And TypeScript will be able to see like, oh, it was a string, so it's got to look like this and be able to, now you can just call wrap as value. But there's another way that's less writing but more complex possibly up here, which is to use generics. And you can think of generics as like almost taking the type as an argument. So here I'm going to write my wrap as value function with almost like an implicit argument, which is like the type of the value parameter. So it's almost like if it's passed a string, my type represents string. And then what we're going to say is we're returning an object that's value property is of my type. So it's kind of like this weird one, like we're reading the type from the argument, and then because based on that type, we know the return value is an object of the exact same type. And once we have that, we can call that function by either explicitly passing the type, so hey, this is the number form of wrap as value, or it can be inferred from the argument. So types, you don't even have to do this. There are cases where you want to do this, and we might see one of those. But TypeScript will just infer it for you a lot of the times and just say, hey, I see that's a string. We're already going to use a string form, and then this would essentially, freak out when you try to call get dollars on high obj. So there's also generic classes. This is very common. Who's used RxJS in TypeScript? So if you used RxJS in TypeScript, you're a lot of times providing type information to RxJS. This is an RxJS subject, which is a form of one of its observables. And here we're saying this thing has to be called, its next method has to be called with a string. Obviously, it's not at this point not able to infer that it's only getting strings. So that's why it actually takes a type as an argument. We can see a similar example. We'll kind of build our own, right now I'm going to kind of build like our own linked list. Or our own, eventually that's what we're going to work to, but I'm really going to build a collection right now. So here I could create a little collection in TypeScript. And the problem with this collection is that its items is any, right? You can push in anything into this collection. And that's not what we want. Really what we probably want is a collection that is either all strings or all numbers. We can see how to define such a collection in TypeScript. So here, just like functions can take a type argument and then reuse that a bunch of places, classes can take a type argument. And this is saying, given the type argument generic collection, the list is an array of the same type. And push item, its thing value, needs to be called with the same type. So when we initialize this, if we initialize it like this, a generic collection, say, hey, you need to be strings, and you call push item, it's already kind of configured to make sure that it's being pushed with strings, and if you push in a number, it's going to complain. So this allows you to create what are called generic types, handle any other type. So just want to show a quick example of a recursive one, and then we are out of here. So I'm going to show real briefly what a generic linked list would look like. A linked list would take a string, or it takes a type, and then it has an unshift that adds things to the front, and a shift that takes them off the front. And you should be either able to pass it, basically pass it a type here, and then it should complain if you try to unshift anything that wasn't matching the type. So an implementation essentially looks like this. We're going to have a linked list node, which is, this is a singular linked list. It just points to the next item, which is, the next item is of the same type. The value it's housing is the type that is parameterized, is the generic type that was passed. and the constructor needs to be passed an instance of that. It saves, or instance of that type of that, and then it saves that value, and its next is always null. So this is like one node in the linked list. It basically has a pointer to what's next, and the type is reused throughout. The linked list itself is kind of organizing all of these linked list nodes inside of it, you know, as a head and a tail that are each a node of the given type. And then unshift is essentially going to create a new node and then point whatever was its current head, point whatever the new node is at the current head, and then point the head at the new node, which is here. Which is really is, you know, that I'm more talking about how to implement a linked list than really type stuff. Mostly it's just this, you're reusing this generic type here. And that's really the magic here is you get that as almost an argument to your entire class definition. You get that type. And that's it. Are there any questions about TypeScript? Thanks, everybody. Oh, yeah.
Yeah, with that operator overloading,
Yeah.
it was. Yeah, for way 2.
Mm-hmm.
Oh no, so yeah, way
Way 3.
Yeah, way 3. So there, can you define different functions with different types that you can overload the operators and have a different function body, or you can only have one function body?
You only have one function. I'm pretty sure you only have one function body, and then in your function body you have to sniff out the type and do the right thing. There's particular ways that I think you have to do that. So,
If I'm not wrong, can you not specify the type using like string or number using the pipe?
that doesn't work, and I don't even remember the explanation for why that doesn't work. I actually asked like why you can't do that in Stack Overflow. I got like this like pages of reasons, and I can think of it again at the end. We can talk, but yeah, you can't. There's a simple explanation, but I don't remember it right now. You can't do that. Yeah.
Can you assign something to be either this type or this other type? Can you like have an either or?
There's unions for sure. Yes, that's what he was mentioning is that there are unions, but that a union doesn't solve this because I think what the answer is like a union type would still return the union type, so it wouldn't know if it was a string or value from that point forward. It kind of has to be like a string or a number that gets returned. Cool. Yeah.
Can your type be like an interface or?
Well, can your type be an interface? So interfaces are kind of treated like types, if that's what you mean. But do you mean can a class be an interface?
Yeah, like if a method return like a type of an interface, but so it could be two things that implement the same interface. So you call a function and can return one of those.
Yeah, you can. Well, you can do interfaces and like do ORs with them as well.
Yeah.
Like anything you can do with for the most part, anything you do with like a type, you can do with an interface. I can't think of I'm sure there's a case where they're disjoint, but create your interface. You can have interfaces. I think there's interfaces of interfaces is allowed. I don't think that's something that I've done, right? There's interfaces that are like ORs of other interfaces that you can do. I'm pretty sure. And then, you just, as a return value, you can specify an interface instead of a type.
Do you use this at all at Bitovi in terms of your client work or as a style? Or
A little bit. So
convention?
there's a lot of people who are in favor of it, and or there's like few people, I should say. There's a small but more growing vocal group inside Bitovi that strongly advocates for it. If we're gonna like take, if I'm putting myself on like what are my feelings about TypeScript, I think it depends on your team and like their experience levels and things like that, right? And the size of the project that you're working on. If I'm working on a huge project and like no one's writing documentation or anything, forcing people to write TypeScript might not be a bad thing. But if I'm working like by myself, do I want to write all of this type checking stuff all the time? Absolutely not. So it really, I think it's a it's a problem. It depends on the situation, I think.
Yeah, yeah. So you'd say, yeah, one of the things, driven kind of by, team size or team
Dynamics,
yeah,
skill
yeah,
sets,
okay.
things like that,
Yeah.
right? Because
That's
it is great to like, okay, I don't know what this API, this person's, it's not documented anywhere, but like I can make sure that I'm calling it in the right way. So I think that's why like enterprise, the TypeScript is becoming very popular there.
Interesting.
Whatever enterprise means.
I think the other advantage is that you get completion in your IDE. It's far more predictable than using just JavaScript.
That's what I'm saying. Like it gives you that complete. You know how the API. If you don't have all the APIs memorized, then that's great because you just like hit dot and you can see all the signatures, what it expects. Cool. All right. Thank you so much, everybody. Matt is going to be next.
Ah, okay. All right. Yeah. So I did not look at the video system. Is this it?
You can use my power if you want. I do too. Put it down there.
How did you hook it up, Joseph?
Oh, it's right here. It's right here. HMI.
I don't think I have it.
Yeah, you do. It's the same thing.
Oh, I'll do that.
Looks about the right fit.
See if it fits.
He's talking about Velocirender.
Yeah. Good. I usually just go in the meetup order, so that's fine.
What was the meetup order?
It was just those last two flips.
This is short, so it's nice.
Yeah. Yep.
Yeah, it's
All right.
very short.
All right.
It's like 5 minutes.
Yep. All right. So next up, Matthew Phillips.
Yep.
Talking about Velocirender.
That's right. All right. Hi, everyone. I'm Matthew. I work with Justin at Bitovi. I'm going to talk to you very briefly. To be very brief, you don't have to leave. You're going to wish you were here, I promise. Velocirender is a really cool tool for speeding up your websites. He doesn't like fast websites, I guess.
TypeScript plus.
But first you have to know about a couple of terms. Who here is what's up?
No.
Oh, that sounds good.
It's a little yeah.
Here it comes. Somebody to turn off mirroring.
Turn off mirroring?
Or sorry,
Turn it on.
Turn on mirroring,
Yeah.
okay. Settings.
Go, yeah.
It's been a while since I've done this.
Arrange and mirror.
Here it is.
Yeah. There we go.
Cool. All right, this is tiny. Oh, not tiny. Tiny for me. Okay, so where was I? Okay, who here has heard of server-side rendering? It's kind of a in vogue term. For those that have not, server-side rendering is there's something called Next.js, which does server-side rendering for React. Vue has its own thing called Nuxt.js, very similar. Or you could just do it yourself with React and pretty much any framework. Angular has one called Angular Universal. So for those that don't know, server-side rendering is a way to take your client-side application and render it on the server. So someone goes to your website, you actually render it on the server, send them static HTML back to the client. That way, well, a few reasons, but one particular reason will be that it helps speed up the what do you call it? The time till first content, to the time to first paint. So the first thing the user can see is they see the fully rendered page. Now, because this is a client-side JavaScript single-page application, you still have to do a bunch of JavaScript stuff to get the thing actually booted up and ready, right? But the user can already see the page, they can, see your content. So that's kind of the benefit for server-side rendering from a performance standpoint. So yeah, there's a lot of different frameworks that do server-side rendering. So Velocirender is that, and the other thing is streaming. So this is streaming. Let's see if you can figure out. This is happening in the client, and this is slowed down intentionally. But streaming just means that instead of doing something
all at once, you do it incrementally. So streaming would be like, this is a streaming API request. Normally, you might do a request for an API, and you're going to get a list of dog products here, and you're going to wait, and you're going to get a whole 20 things all at once, and you're going to inject them all at the same time. But that's not always ideal, right? Because in this case, this is really slow. So if we waited for the entire thing to finish, it would just now finish. Is all, I guess it's done, yeah. So it would take a while, right? So streaming is a way to get something to the user as quickly as possible. Does anyone have an idea of like what's a good use case for streaming? Like why would you ever need this? Do you want to have any idea? So think about, well, I guess what I'm getting at is sometimes database queries are slow. If you have like, if anybody's familiar with databases, you could have some complicated joins and like, those things are slower, but if you're just getting a user by ID, that's going to be super fast. The things like cached, right? Or if you're doing like search results, now you're actually doing some really complicated stuff. So I guess what I would say is some things are slower than other things. And what streaming does is allows you, and this is what Velocirender does, is it allows you to not let the slow parts of your application slow down everything. So Velocirender, this exists, and this is powered by a newish DOM API called a readable stream. You don't really need to know a lot about that, but it provides a way for you to do this in the browser. So I work on a project at Bitovi called DoneJS. DoneJS is our framework, and it does server-side rendering. It's one of the things that we've always done. It's the best at it, I promise you that. And we were kind of learning about this stuff, and we were thinking like, how can we use this new streaming thing to like improve our server-side rendering? One bad aspect of server-side rendering from a performance standpoint, it's really nice that the user gets to see the page as quickly as they get to see something, right? But before they can see something, we have to do everything on the server. So what most server-side frameworks do is they do everything on the server. They kind of, those slow database requests, they do those, and they got to wait for everything to finish, and then they send you all the HTML. And they don't have to redo it because they've kind of packed the API results with the HTML, so they don't have to redo it on the client, but kind of that first push can be slow depending on how slow your database requests are. So we were like, hey, how streaming allows you to like make things faster, and server-side rendering is good because it's good. So how can we combine these two things? And Velocirender is the answer. So Velocirender does something just absolutely insane, which is it takes your application. Then this can be. Let me show you an example real quick. This is the same thing I was just showing you, but server rendered. It can take a React application. It can take a Vue application. It works with any framework. It's completely agnostic, and that's because it implements a DOM on the server. It actually uses JS DOM, which is kind of a popular package. And it just renders Angular the same way that it would. I don't know if our mouse is working. There we go. Okay. It just does everything it normally would do, but it has this one little trick. And what that is that it takes your application, it renders, instead of waiting for all those API requests to finish, it just sends you what it's got. It just says, hey, we've rendered this so far, let's go ahead and send you this. And then in the meantime, it connects, it uses this readable stream thing, it connects back to the server. The server's still doing the normal stuff. It's making the API request, it's getting that list of dogs. It's going to send these little commands. It's like, hey, you need to add an LI, or you need to add this image, or in this case, where's the example? This has like a cart count too. So one of the cool things here, you'll notice here on the left is the Velocirender. You notice, wait, did that actually happen? Well, it might not sync up perfectly, but a lot of times what you'll see is it's too fast. Sorry. What should be happening is that, what can happen is that you start getting results from the list before the cart count's finished, and that's because the cart count kind of in a complicated query. It's like you have to like look up the user session, and you have to look at might have to hit another table to get the cart count, and that's just going to be a little bit slower than streaming a list of things. And one of the cool things that Velocirender does is that because we do this kind of dynamic way, we don't have to wait for the slowest part of our application, the card count, to start rendering stuff. We can just start rendering this list, and when the card count's finished, it's finished, we'll display it then. So yeah, we have here on the left, we have Velocirender. Just going to do a refresh. It's going, and this is the client version. This is only client, no server rendering, and it takes, in this case, it was 1.3 seconds faster for Velocirender to finish the results. Because it's like a head start, you know. Your application has to do all this stuff. Anytime your application loads, you send it HTML. It's got to load link the style tags. It's got to get the script tags. It's got to do all that. Once the scripts actually run, then usually you're going to make a database request. That's what this is doing. So there's all this front-loading stuff you can have to do before your application finishes, and it's kind of a waterfall type of problem. And Velocirender just like says, forget about all that. We're just going to kind of supercharge this thing and get as much out there as quickly as possible. All right, I've probably taken more than 5 minutes. Does anyone have any questions?
In your intro, you had mentioned that this increases time to first paint. Does this have any effect on time to interactive?
This does, because remember that one thing that slows down server-side rendering is that we have to do all this stuff on the server before we can send the HTML. So the browser still has to fetch those scripts and everything to make it truly interactive, right? It has to fetch the scripts, run the scripts. It has to do all the same stuff it's normally going to do, but because we're doing server-side rendering and we're waiting, it's going to be slower. But with Velocirender, we don't wait. We're like, hey, get started right away. And that's one of the big benefits, is that we get you HTML as quickly as possible. The browser's going to start doing all the fetches, and it's going to get the interactive point as quickly as possible. It's actually interesting about Velocirender is that there's kind of two things happening. You have the application booting in the browser, and then you also have this streaming thing that's updating the DOM, and they're kind of racing each other. And sometimes the client thing actually finishes before the streaming's done, and it kind of like takes over, if that makes sense. It's like, hey, I'm done. You don't need to keep doing what you're doing. I got it from here.
So the use case in the industry is limited to specific domain, like purchasing in Amazon, like your items rendering as we want to store, or suppose we have some financial data, cannot wait to like render some charts, like 10 charts are there. They should render with the all data at once.
You need to render with all data at once?
So okay, it's not limited to any.
It's not limited in any way. It's just this is a case that's like makes it really beneficial. Is you have some parts of your database that are slower than other parts, and you know you want to get the user something quickly as possible. E-commerce is a great example because you know there's papers that have been done that shows the quicker users see information, the more likely they are to see it on the website. Yeah.
Would you say Velocirender is almost all upside and no downside?
No, there is one downside. There is. It doesn't do SEO. So if you really need SEO, which nowadays, I don't know if you guys have been reading, but Google now does a lot of JavaScript. I think they have like the latest version of Chrome that does their web crawling. So nowadays, JavaScript is already happening. You're already getting SEO from JavaScript apps, so it's less of a advantage. So
I was talking more about in terms of performance, because you said like, considering the race, if you had a client rendered app, that's still running.
Yep.
So there is no case where it runs slower, because the same app is running how it was previously run.
Right.
It's just now you have a head start.
Yeah, it's like
It gives it a possible head start.
Yeah. The best case scenario is your app, it loads super fast. You have a really good connection, like your users, like the CDN's like right next door, and they're like getting that data super fast, and that's fine. But you have a user that's like in Alaska. I'm sure they have good internet in Alaska, but let's say that they didn't, and it takes a little bit longer, and that user is going to get the benefits of this that way.
Would it lend itself well to a progressive web app?
I can't see why not. I hadn't thought about that.
It's mostly on first load is what it's trying to
this is benefiting first load. I guess that's a good point. Yeah, this is, I guess, this would be best Best case is for a brand new user, someone who's never been to your website. There's nothing cached. Like you want to get, like, you know, you really benefit from like your users getting your website as quickly as possible. You want to get everyone that you possibly can. Very frequent users, you've got a service worker installed and stuff like that. You know, this is not going to help you there because, you know, you've already gotten pretty much what you need. Yes, this is more for first page load.
For this first one, it's like JS DOM. I'm not as familiar with the readable streams. Would it be possible to support it on other backend?
Like it's pretty much tied to Node.js.
Okay.
But it's like but it's like its own server. You don't have to, you can run it
you
next
proxy.
to whatever other backend servers.
Okay.
It can be its own little thing.
Yeah. So like
I think a lot of people are doing that anyways because, you know, a lot of people are writing completely front-end JavaScript applications. Their backend might be in PHP or whatever, but they're not actually doing the DOM rendering that way. They're using a Node server and setting up React, and, you know, you just then in Nginx you proxy to this, to that.
Like a dogs flow, like Rails app.
Yeah, sure. You could do like your API there and then do something like this.
Is there really such thing as orthopedic backbone?
Yes, I took these straight off of Amazon, so there is. My dog has this cozy cave one. You can go inside of it. It's really cool. I recommend if you have a dog. Mine loves it.
All right.
Cool.
Thank you. All right. Next up, we have Kevin Phillips.
No relation to me.
Oh, okay. Makes sense.
Did you work together?
Oh, he's got an adapter. Okay, right. All right, cool. So Kevin Phillips, Chrome extension scripts. Are you get the mirroring again?
Yeah.
Okay, cool.
Almost. Oh, I don't hear. Oh, I screwed this up. Turn mirroring off.
Hmm?
How do you turn mirroring back on?
Should be a thing under arrange. Checkbox under arrangement, I think.
There's no more.
Oh.
Somebody out there is thinking.
They put a thing in the toolbar. Sometimes they do that.
Yeah, unplug and plug it back in, maybe.
It's probably on the other.
Yeah, no, this is right there. This is right here.
Oh, is there a tempo for it?
Oh, there it is.
Yeah.
There you go. Yep. Thank you.
Turn it off, turn it on again.
How many JavaScript browsers? All right. Let's see anything else. Good. All right. I am Kevin. I'm also a JavaScript developer at Bitovi. We work on web apps, and I also work on a framework called CanJS. For the last year or so, I've been working on our Chrome extension for CanJS DevTools. And this is going to explain everything that I learned in that process and help you get started building a Chrome extension if you're interested. Some of this really goes into the weeds of the different scripts in Chrome extensions, so please feel free to interrupt me as I'm going. All right, so what we're going to talk about is things you can do with Chrome extensions, why they're cool, why you might want to build one. Then I'll go through the details of all the different scripts that I just mentioned that are involved in building a Chrome extension, and then we'll go through a quick example of that. Cool, so Chrome extensions allow you to extend the Chrome browser in a bunch of interesting ways. You can read these bullets, or I'm going to go through some images to show you a little bit more interesting. So obviously I mentioned CanJS DevTools, so Chrome extensions allow you to extend the built-in DevTools that are available in Chrome. You can add new panels and add new sidebars to the panels that exist in Chrome already. Chrome extensions also let you add new items to the context menu that shows up when you right-click inside of Chrome. This is a pretty popular thing to do. I only use a few Chrome extensions, and like 4 or 5 of them do this. So very popular. Another thing you can do, they let you override some of the built-in pages in Chrome. There's a ton of extensions out there for replacing the new tab page. This is one called Tabby Cat, which shows you a different cat every time you open a new tab. It's kind of interesting. You can also replace like the bookmarks manager and the history page and any of the other built-in pages. Extensions also let you pretty much overwrite anything you want in the content of a page. This extension is called Cloud to Butt, and it went kind of viral a couple years ago, and it really just changes the word cloud and words that are related to cloud computing to the word butt anywhere in any web page that you go to on the internet, which is pretty amazing. Cool. Now that you all want to build your own Cloud to Butt extension, let's see how you can do it. When I first started building a Chrome extension, I was really kind of overwhelmed by all the different scripts that they talk about in their documentation, and the things that are possible in each of them. They all kind of have different functionality, different ways of communicating with one another, and debugging each of them is a little bit different. So I'll go through kind of each of these things in these 4 scripts. All right, so before we talk about that, quick aside on this manifest.json file. Every Chrome extension has to have one of these. It basically configures the extension, tells Chrome what your extension does, and sets up like the permissions that the extension asks for in the Google Web Store or whatever. A lot of the scripts that we'll talk about later are configured through this file, so this is kind of the minimal configuration that you need for a Chrome extension. And then all of the stuff we'll talk about will build on this. There's a link to more documentation if you're interested. I'll post these slides later. All right, so the first script that we're going to talk about is called the content script. Content scripts are injected declaratively, like in this manifest.json file, like I mentioned. They basically tell Chrome to, this configuration here tells Chrome to load a JavaScript file on any page that matches this lot pattern, and then it also says load it in any frames, any subframes of that page. They can also be injected programmatically through some Chrome APIs, but I've never done that. But they show it in their docs if you want to do that. All right, so content scripts run in the context of the user's page. They, like this says, they share the DOM with the user's page. If you're unfamiliar with the term DOM, this basically just means like the objects that represent the content of the web page. So this basically means they can access any of the page's content and make whatever changes they want. This is how the Cloud to Butt extension works. It just inner HTMLs the page and changes everything. So yeah, if you had a content script like this, basically every page that you visit would be changed. It would change the body of the page to say bye-bye. Pretty simple. While they share the DOM with the user's page, they run in their own JavaScript context. So this means you can't read any variables. In the content script, you can't read any variables from the user's page, and you can't create any variables to mess with the user's JavaScript. So basically, if you had a content script like this, cool thing would be undefined inside of your content script. Even if you try to do something fancy, like looking up the window through the default view of the document, that still doesn't work. They figured that out too. I thought this would work, but it doesn't. Since they share the document with the content script, you can communicate between your normal page and your content script using normal DOM events. So here in the user's page, we can see this is dispatching an event, and then in the content script, it's listening for that event type. And you can do this. Normally, you would do something like this when something happens. This actual code might not work because of how the order of when these things happen. So this might not work, but normally, like, user would do something and then you would dispatch an event. And the communication can go in either direction. There's also some Chrome APIs that you can use within a content script. This makes it possible to communicate between the content script and other parts of the extension, and we'll see what those are later on. And you can do this either way also. So debugging a content script. If you create a script like this and you want to debug it, make sure that you're changing all the clouds to buts. You can do that in the normal Chrome debugger. They have their own tab, so you might have to, they have their own panel, content scripts, so you might have to find them in like this overflow menu right here. You can click on this and say, find content scripts, and that's where you can debug these. You can also like Commando or Control-O, if you know the name of the file. That was a lot. All the rest of the scripts build on this. They all they're not quite as complicated, and they build on this. But here's a quick summary. So content scripts, I mean, you can read this later on. We'll move on. All right, injected scripts. So what I'm calling injected scripts aren't exactly a feature provided by Chrome extensions, but since content scripts share the DOM with the user's page, a content script can inject a normal script tag into the user's page, like this. And you can also use this, Chrome provides this API for getting an absolute URL to your script so that it'll actually work. So once you do this, you can actually find these scripts here in the HTML like this. You can see this injected.js gets added at the end of the body tag. If you want to do this, you have to, in the manifest, you have to make sure that that file is web accessible. So that's something that tripped me up when I first started doing this. So scripts injected like this can access the DOM of the user's page, and they also can access any JavaScript. They share the same, they run in the user's page. So if you throw an error inside of your injected script, that's going to break the user's page potentially. But you can use them to do things like this, like creating cool global variables inside of your injected script, and those will be accessible on the user's page. If you've seen this kind of thing in React, a lot of DevTools for different JavaScript frameworks will do this sort of thing so that the framework itself can hook into the Chrome extension. So like React creates this React DevTools global hook variable on the user's window so that React can tell the DevTools that that page is using React and all this kind of stuff. Injected scripts and content scripts can communicate the same using normal events, just like we saw with the previous one. Injected scripts can't use any Chrome APIs because it's running on the user's page. It's not running inside of the extension. You can debug injected scripts just like content scripts in your normal Chrome debugger, but they're in the page sources instead of in the content script section. So this is like where your actual code is. All right, that's review, but let's move on. So background scripts are scripts that run in the background. They basically run one time. They're there all the time, basically listening for events that come in from other, or events or messages that come from other parts of the extension. So some events that you might want to, like, if the user navigates to a new page or removes a bookmark or closes a tab, you might want to dispatch an event and have your background script do something to it, just to this. They're injected declaratively, just like the others, or the content script that we saw in the manifest file. So when I mentioned in my first example, we'll see this later, basically the background script is one of the things that you might listen for APIs, or listen for messages from the Chrome APIs that we saw. So debugging background scripts is a little bit hard. You have to actually go to this Chrome extensions page and click on that inspect views button there. That background page there is a link, and that'll actually open up a separate debugger. And you can see this is like the generated background page HTML. So this is debugger just for that background script that's running. All right, so the last thing I'm going to talk about is DevTools pages. So this is basically used to extend Chrome's DevTools. They're not exactly scripts, they're actually HTML files, but you can load a script inside of an HTML file. These can be used to create DevTools windows or, DevTools panels or sidebars and other panels. They can communicate the same way. You can use these basically to create panels inside of DevTools. So this one is, you can see it's doing Chrome DevTools panel create, and this is actually creating one of these top level panels, this sample extension. That's what Chrome's DevTools calls panels. You can also use them to create sidebars in the Elements panel. So this one creates this little sidebar. So you're on the Elements panel at the top, and you're adding this panel over here on the right. You can do the same thing in the Sources panel to add something down there in the Sources page. All right, so once a panel or sidebar is open, it can use a bunch of Chrome APIs as well. One of them that's really useful is this inspected window eval. You can basically use this to run some JavaScript in the whatever page you're inspecting. This is a way you can access the JavaScript context. You can access any of those global variables that you created, anything like that. To debug this, you can basically right-click inside of the panel, and that will open a debugger to debug the debugger, and it's very meta, and you'll feel very cool doing it. All right, so real quick, I'm going to run through building a simple extension. It's going to do these 5 things. Basically going to show an icon up in the Chrome toolbar. We'll add a new panel in Chrome DevTools, update the toolbar icon whenever that panel is open. So basically we'll just, like React does a lot of these things too, saying like, this page is using React. You'll see the icon turn red or whatever they do, I don't remember. And then we'll also add a global JavaScript variable to the user page, and then read the DOM and display it. Basically build our own version of the elements panel that already exists. I'm showing this example because this is basically the hardest thing I had to do for CanJS DevTools, is build that. Cool, so these are our videos that are very tiny. So in this first step, we're basically going to make a simple manifest JSON file that I showed at the beginning, and it's going to add a few images. This is going to add this icon. So basically there's just a configuration that says add a default icon that shows up whenever you want.
Kevin, there's a full window you can hit. If you want to configure. You hovered over it, that's it.
It's already done. Okay, sorry. All right, so then we go over here to this Chrome extensions page, load the extension so that it'll actually work, and then load up a new page, and you can see up here there's this little vomiting icon. I'll move to the next slide, hopefully. There's a bigger image of this. So you can see there's this guy throwing up here that you see up at the top. Cool. All right, so this next step, get started. Bigger just thing. Cool, so this next step, we're going to create the DevTools page. So you can do the same thing. You have to configure it in the manifest. We'll create an HTML page, this index.html, and then this index.html is going to load a script tag, basically, and then in that script tag, we'll use some Chrome APIs to create the new DevTools page, and then also create the HTML for this page. I don't know why they don't let you just use a script tag for this. You have to have this index.html that doesn't get displayed anywhere. But last time I did this, I tried to make the video faster and I screwed it up, so I'm not going to try. Cool, so this creates a panel called sample extension. It's got its own image, and it loads this other panel HTML file, which does the same thing. Loads, creates some HTML. Once it's full screen. All right, so we go back here. I always forget to reload it, so I'm showing it there. You can click that reload button and it'll reload your extension. And then if you inspect your page, you get this new cool button here, the extension. All right, so when this is done, you basically have a button panel and it doesn't do anything. All right, the next step, all we want to do is update the icon. So whenever a user is using your new panel, we want to update the icon so it's not throwing up anymore. Okay, so this is going to, in our DevTools panel, it's going to call this connect function. So basically, a background script can listen for that connect, or listen for that message, know that something's connected, and update the icon. So now we're going to add a background script that runs all the time and can listen for those messages to come in, listen for any new DevTools instances that open up. You can have, you can be debugging a bunch of different pages at once. This runs once, listens for this. It's going to add this listener, and it does this check just to make sure that somebody else didn't connect. It's actually our extension that's trying to connect. And then it's going to update the icon when you connect or disconnect using some more Chrome APIs. do that on connect and then also on disconnect. So we can change it back to throwing up if you close your DevTools. The reason I show this, like React does this kind of thing. If you're on a page that's using React, it'll say this page is using React. And if you're on not using the page not using React, it'll update it to say this page doesn't have React. Yeah.
So who's connecting to who?
Yeah. So the sample extension that we saw that just says hello. That is where I put the connect message. So it's sending connect, and then the background script is running all the time, listening for that message. So yeah, the background script is basically the thing that runs all the time and listens for other pages to connect. And the thing that's connecting is the extension itself. So now when you're done with this, you can see now we've got this guy with glasses instead of the throwing up guy. All right, this is the last step. This one's a little bit longer, so I'm definitely going to speed this up. All right, so in this last step, we want to actually read the DOM of the user's page and display it in our DevTools pane. So this is going to create a content script, and then that content script is basically going to do that thing we saw at the beginning, inject an actual script into the user's page.
So there's a DevTools page, there's a background script, there's a content script, and then DevTools is trying to connect to the content via the background page.
So there's a content script that's going to inject an injected script in the user's page. That injected script is going to read the user's DOM and then message it back to the DevTools page, or the DevTools page. So yeah, there's a lot going on.
You don't have to route it via the background page.
You don't have to route it via the background page. No, you can connect directly from the content script to your DevTools page. So this one, this is creating a button, I think, in the div. This thing. So this basically just adds a button and a div to the DevTools page. Is basically the button's going to be a reload button that's going to look up the user's HTML, and then the container is the place we're going to put it in. There's a ton of code in here that actually that actually reads the user's HTML. That stuff's not as important. You probably don't want to build this exact same thing. But
what is a background page, a background script allowed to do that content script isn't?
So the content script runs once per DevTools instance. So any DevTools window you have open, let's say you've got 5 Chrome tabs and you're debugging, inspecting each of them. There's going to be 4 separate content scripts. So the background script just runs one time. So it's basically like a more long-running process that you want to listen for things to happen.
Is it also allowed to do things like access the file system and get out of the browser sandbox?
No. Everything, is running from Canton. So yeah, I'll skip over the code that actually reads the user's page. Skip over a lot of it. And now we can see basically this button lets you can click it, it reads the DOM of the user's page and displays it there. Glossed over a lot of the middle part there because it's not really about Chrome extensions itself. It's more related to this one. So yeah, when it's done, you have this cool extension that is an uglier version of the Elements panel. That's it. I'll post the slides like I mentioned. The sample extension code is on GitHub. You can look and it does that. You can figure out what all the scripts do. Questions? Yes, ma'am.
I've read that Firefox has similar APIs now. Do you know how hard it is to port something like this over to Firefox?
Yeah, that's a good question. So Firefox's DevTools does, I think, have almost identical APIs to Chrome. So all the things where I'm doing Chrome whatever APIs, I think those are all supported also inside of Firefox. I know the React's DevTools and Vue's DevTools is basically the same code and they run in both places. But I don't know exactly how it works if you have to replace Chrome with Firefox, or I don't know how the APIs are laid out, but I think they support all of the same APIs. Yeah.
Can you view the source code of any plugin you have installed in Chrome?
Yeah. Well, Yeah, it might be kind of hard
Is it,
to
can
find.
you just look like you did in that example, in the extensions, in the development tools? Or?
Yeah, let me, so if you go over here to sources, the problem is that a lot of it is obfuscated, so like the names of the files are.
Can't you go to the Chrome extensions in a new tab, and can't you inspect from there?
For background pages, you can.
Oh,
So yeah, you can see in here the content, but that's not necessarily every extension that you use. They might not all be using content scripts. Most of them probably are, but they might not. There's not like one place where you can find all of the code for a specific extension. Yeah.
Do you find a good resource on Google about making Chrome extensions? I made some, but it's always a struggle to find something current and something that you don't have to fart around with to get working.
Yeah, that's exactly what I found. Like their docs they're there, and they have okay examples. But if you're not trying to build exactly what they're trying to build, I didn't find any great examples.
So you just grinded it out to get it to work?
That and I read a lot of code of what other similar sorts of devtools are doing. But yeah, I don't have a great answer, but that's why hopefully this helped. Yeah.
Is there any way for a website, perhaps through a Chrome extension, to actually communicate with some kind of local desktop software that's installed? Could be through a port, could be through anything else.
Yeah, I mean you can make XHR, you can make API calls from your Chrome extension, and they can do that. I don't think they block that sort of thing. And they
I've seen
don't
things using
reject
localhost
it.
servers to communicate to a web page.
Well, do you run into problems because of them not running on HTTPS?
I don't think it would. I mean, at least for the content script, the protocol is like the file. It's not an HTTP page. It's like a file. Like the content script is served basically from the local file system. So I don't think you would, but I haven't tried. Yeah.
I imagine that Chrome extensions could be used for nefarious purposes. And do you have any tips on how we can identify and protect ourselves from bad extensions?
Yeah. So like I said, they can basically do whatever they want, and the only security that you have is reading the permissions that they request on the page where you install them. So I think that's a big thing. So like anything that I put in the manifest.json, those get turned into actual permissions that you ask for. So if I have a content script in that manifest file, then on Chrome's web store, it's going to tell you like this Chrome extension can read and write anything in your page, and they'll give you that kind of thing. So that's the first place to start is obviously read those. But I think they all have to be kind of installed through Chrome's web store, so you also have like user reviews and that kind of thing. But yeah, they can do whatever they want. That's kind of the biggest thing is like they can change whatever they want to. They just have to tell you they're doing it in the manifest.
And what has been your experience with the stability of these APIs? Because I've heard about how new Chrome versions, particularly Canary, constantly breaks some of these contracts, and also about how recently content scripts were allowed to access local storage, but you can't anymore.
Yeah, the APIs that I'm using for our extension, I haven't run into problems with them being changed. I don't know how many of CanJS developers are using Chrome Canary. Like that sounds very plausible that those would break all the time in Chrome Canary.
But and that continues to be broken in the next build.
Oh, gotcha.
Yeah.
Okay. Yeah, I haven't run into that, but yeah, it certainly sounds plausible. They're not features that are used on websites, right? So Google doesn't have as much invested in keeping them stable.
Is this Chrome extensions the current model also their future, or are they trying to downplay this as the feature, because if you really go to Chrome and try to find extensions, it's really hard to get to the web store.
That's true. Yeah, it's not super easy. I don't have any. I don't know. I don't know if they're trying to get rid of them or not. But yeah, it's a good question. It's definitely something I should find out before we invest a lot more in building it. Good question. Thank you. Anything else?
All right. Did you have one more question? No? All right. Thanks for coming out, everybody. We don't have anything on tap for next month?
Not officially.
Not officially.
No, okay. Yeah, so if anybody has anything you want to talk about?
Hosting,
Oh.
we will
be
be
here.
hosting
Okay.
again here. The plan is for our CEO or some of our devs to talk about our in-house grid canvas framework. Yeah, but that's
Okay, so you're planning to do a talk, you just don't have it set up
Yes,
yet.
yes.
Okay, cool. So we should have that for on type for next month, but we're always looking for, if you have anything you want to talk about, anything you want to explore and then report on, or even if there's something you want to hear about, we can try and find a search on that, or a presenter or speaker for that, yeah. And as always, if anybody wants to kind of get involved in the community, we would love to have some help on organizing things and setting all that up. And otherwise, have a good night.